Hello YouTube, this is George from the G&M Home Movies channel. Today's video is about resurrecting, or attempting to resurrect, that old solar panel up there. It's been up there since 2016, so that makes it about 8 years old. It's a 100-watt panel I bought from Windy Nation. If I can get that thing working, I got big plans for it. So we're going to start in here. This is where the equipment used to be. Got this 30 amp charge controller, and it was mounted right there. And had this fuse block, which was mounted there. I had several switches. I'll put up a picture of what it looked like once I had it completed. And it had a car battery sitting up here, 12-volt car battery. And this is the cable that I'm going to remove today. This goes to the panel itself. So this 12-volt system worked okay. It worked fine for lights and motors and pumps and things like that. But I wanted to use it for electronics, and it did not work for that because the voltage varies too much. I'm going to take this wire out and then climb up on the roof and remove the panel. But you know, before I do that, I'm going to put a voltmeter on the, see if there's anything there. Yes, we got 20.2 volts, which is I think pretty darn close to the open circuit voltage, so that's a good sign. That means it's still working. It's a cloudy day today. It's overcast, but yeah, that's encouraging. Alright, so that wire's stuck in there pretty good, so I'm going to try a different approach. I know I got connectors in the back, so I'm going to disconnect the panel from the wire. Alright, the panel is off. The wires are cut. So this is my outdoor workbench. So I got a bunch of rags and some different kinds of cleaners. I'll see if I can clean it up. Sitting up on the roof for 8 years, it's gotten pretty grimy. coming up. Alright, well that's going to take quite a bit of elbow grease to get clean. But this should be good enough for my test. What a mess. Alright, so I'm going to load everything up in the truck. So, if all goes as planned, this is where the accident is going to take place. That right there is a shallow well, and we're going to take a closer look at that in a few minutes. But first, let me show you around. So this here is going to be a pollinator garden. Instead of having grass, I'm going to till it up and plant wildflowers. And my plan is to put a water feature in the middle of it with a fountain. And that's where the solar panel comes in. So let me show you what we got. So here we got the solar panel, and this is a battery, second-hand battery, but it still works just fine. And this is a pump, a 12-volt clear water pump, probably 20 years old, and it still works. But we're gonna test it again. I planted all those trees along the tree-lined driveway, and I used the irrigation system to water them when they were young. They're big enough now; they don't need to be watered and pampered. But so my big plan is to use this little pump, this little 12-volt pump, place it in the shallow well, which we're going to take a closer look at, as I mentioned, that thing right there, and hook it up to the solar panel and the battery, and have it pump water out of the shallow well over here to the pollinator garden and to the fountain in the pollinator garden. Right now I'm just going to test to see if the pump has enough lift to get water out of the bottom of the shallow well. So let's take a look. I haven't looked in this well for a long time. Contact. All right, no luck. Well, I'm going to try this experiment again, but I'm much better prepared this time. First up, I got to attach the pump to a piece of wood so that I can clamp it on here and not worry about it falling over or having a hose pull it over. Next, I got a longer longer intake hose with a foot valve, and I put this big piece of pipe on here as a weight to hold it down into the well. And then the next thing is I gotta put this T-fitting so that I can prime it. That way I can fill the hose up with water and hopefully have it work. So the reason I'm doing this experiment first is because if the pump doesn't work, then it's no sense in testing out the rest of the stuff. So this is the important part. Let me tell you a little bit about this shallow well. I built it in the winter of 2002-2003. It goes down into the water about 3 feet. So here's the intake tube. It's got a brass foot valve on it. You can see from the coloring it's probably in the water about 3 feet. I have an electric pump here, and it's a AC powered electric pump. It looks pretty awful right now. It's all cruddy and rotted, but here's a picture of what it looked like when it was all shiny and new. The pump would pump water into this manifold where I had a series of check valves and pressure regulators, a screen, and some tubing for valves or gauges that I had up there, and it worked very well. Let's get back to this test. So I got the input hose set up, got a short piece of hose here. Hopefully water's going to come gushing out of there any second. See if I can prime this thing. All right, here goes. And we got water. Woohoo! All right, that's great. That's very encouraging. I do want to check to see how much current this pump draws. 9.5 amps. So that's quite a bit at 12 volts. I don't know why it was acting so erratically. The foot valve I have on here, it's got a pretty stiff spring, so might not be able to easily come over that foot valve. All right, so that's a successful experiment. So next, I'm going to test out the charge controller and the solar panel itself. So this is just going to be temporary. So I'm going to lean it up against a tree. So to make this experiment a little easier, I mounted the charge controller to this piece of plywood, and I'm going to set it right here. There's a squirrel's nest in there, like that. And I got the wires, I pre-made the wires for the batteries and the solar panels. Just reaches. That's for the battery. So I got this Anderson connector for the battery, so I can easily disconnect it. Also, I put a 20 amp fuse. That should be good. Here goes. Got some things on the display. It's 12.5 volts on the battery. And a solar panel. So that quick, it jumped up to 13.8 with the input from the solar panel. And it's charging the battery. Woohoo! .7 amps going into the battery. .7 amps coming from the solar panel. I gotta do something to keep the rain and the snow off of it. That's temporary. So this is good. I'm going to let this cook for a while, see if it'll charge up the battery some more. 13.8. And then I got some wire to run from here. I put this disconnect on there for two reasons. To connect the wire that's going to go to the pump. I'm not going to put the pump on right now because it's going to snow. I don't want to get it snowed. But this will allow me to disconnect the pump for servicing. It also allows me to transition from the stranded wire I got going to the controller to the solid conductor 10 gauge wire that's going to go down there. Alright, so that's the second experiment. So far successful. So I'll keep an eye on it, check on it every now and then. The next step, we'll set up the pump after I take a look at the check valve and see if I get that working. So I'm making some changes to my test setup here. at 13.9 volts. Battery's fully charged. There. I wanted to be able to get this bag over there and keep the weather out. Alright, so next thing I'm going to do is run a wire over to my irrigation control box, because I have a voltage gauge mounted on the wall in the house that I used in my previous system, and so I want to get the voltage from the battery up to the house so that I can keep an eye on the battery voltage without having to come all the way down here. So this is the irrigation control box. Got an irrigation timer that I used with the AC powered pump, and I got a series of pressure gauges. There's a pressure switch and a pressure gauge. So one of the pressure gauges shows the pressure before the regulator, the other shows the pressure after the regulator. And then I got a series of irrigation valves, because I got 3 valves that the timer controlled. One valve controlled the trees on the west side, or controlled irrigation for the trees on the west side. The other valve controlled irrigation for the trees on the east side, and the third one controlled the irrigation for our old vegetable garden. But I'm going to be working back here on the back side of this box. So this junction box here is connected to a big 10 gauge cable that goes up to the tool shed, because originally when I had the solar panel and the battery in the tool shed, I used this to distribute the power down to here. So I'm going to be using that to get the voltage from that up to eventually up to the house. So this other end I'm going to connect to the battery. I got a 5 amp fuse on there so I don't blow anything up or melt any wires. here at the tool shed. This is where the system used to be. Right, the battery was up here, and the controller was here, and the fuse box, and then this is my distribution network. So this takes the 12-volt power down to the creek where we just were hooking up the monitor wire, and this goes up to the house where I had some electronics. So today all I'm going to do is jumper these two together to get the power, get the signal from the creek to here, and from here to here, and then from here up to the house. Alright, so that is taking the 12 volts from the creek to here, and up to the house. So this is all just temporary. If the system works, and I'll install it permanently. Alright, now up to the house. So here we are in the basement of the house, and this box connects there's a big heavy-duty 10-gauge that goes down to the shed where we just were. And I already have a jumper installed that goes to this terminal block there, where this other wire goes upstairs to the meter. And here we are upstairs, and there's my meter. So it's showing 13.6, 13.7, 13.8. That's pretty close to what we were seeing down by the creek. So this way I can keep an eye on it every time I go in and out of the door. I can check the voltage and make sure it's doing what it's supposed to do. We made it to the last step of this grand experiment. So I'm going to put it all together, hook up the pump to the charge controller, and see if it works with the battery going through the charge controller to the pump. I took the spring out of the check valve, so now it works strictly on gravity. That should make it easier for the pump to overcome the check valve. Well, now the check valve doesn't work. So I guess I gotta put the spring back in it. Alright, let's try this again. Got the spring back in the check valve. There we go. Battery's fully charged. Make this connection. The big moment. Solar panel connected to charge controller connected to battery, pump connected to charge controller. Pump running but no water. I really got to figure out a better way to prime this. I think that's the problem. We got water. There's a restriction, a kink in the hose. So we're down to 11.9 volts that quick. So when I rig this thing up permanently, I'll probably going to have to get a bigger battery. And there's the solar panel. Nice bright sunny day. collecting the juice. Now when I install this thing permanently, what I hope to do is the charge controller can be configured to turn the load on at a certain voltage and turn it off at a certain voltage. So, so maybe I'll have it turn off at 11.5, and then when it charges back up to 13, turn it back on, and that way it'll cycle the fountain. Alright, well that's it for this experiment. It works. Got a few kinks to work out with the foot valve, but other than that, it's a success.